In this lecture, we'll introduce Boolean logic and Boolean expressions.
We'll now introduce a new type of value, which we call the Boolean value, which just simply means that this value can either be true or false. And this is primarily used in the construction of computer circuits. And this is based on a branch of mathematics and symbolic logic that we call Boolean logic. The idea of this area is that we can manipulate these Boolean values. And it's used, as I mentioned kind of a little bit, that's used to construct circuits. And these circuits will perform operations such as adding numbers, comparing numbers, fetching instructions, and so forth. And it's really easy to see that there is this relationship between Boolean logic and computer design. Because we have these Boolean values that are true and false, we can say that true would represent the binary value 1, and the value of false would represent the binary value of 0. So anything stored internally as a sequence of binary digits, which is pretty much everything, can also be viewed as a sequence of the logical values true and false. And then we can manipulate these values by using operations of Boolean logic. Now we're going to define a Boolean expression as an expression that evaluates to either true or false. So just to give you a simple example, let's say we have x equals 1. This is a Boolean expression because it's true if x is in fact 1, and it's false if x has any other value. In traditional mathematics, we have operations to construct arithmetic expressions such as addition, subtraction, multiplication, and division, which maps real numbers to real numbers. Now, in Boolean logic, we have just three main operations that map a set of true-false values to a single true or false result. So these expressions are what we call and, or, and not. And we're going to go over each of these in more detail. Let's start by taking a look at the AND operation. So let's suppose we have two Boolean expressions, which we'll call A and B. The way we denote the AND operation is we would just simply say A and B, where AND is in all capital letters. This allows us to distinguish from the operation and then just the word and in a normal sentence. There is another way we could denote this. We can use A dot B, that also means and. So either one of these is perfectly fine, but we'll most likely use the AND operation rather than the dot, but either one is okay. Now, the way the AND operation is evaluated is we say that A and B is true if and only if both A is true and B is true. So if they're both true, then A and B will evaluate to true. Now, if either one of these is false, so if A is false or B is false, or if even both of them are false, then we say that A and B is false. So the way we can think of this is if they're both true, then the AND operation evaluates to true. And if at least one of them is false, then the AND operation evaluates to false. Now, a way that we can illustrate this is we can use what's called a truth table. And what this table does is we look at all of the true-false combinations for our Boolean expressions, and then we can see what the AND operation would evaluate to. So in this case, for A and B, we have four different combinations. We have that A is true, B is true, A is true, B is false, A is false, B is true, and A is false and B is false. So these are all the possible ways that we can have true and false for A and B. And from this, we can tell what A and B would evaluate to. So here, if A is true and B is true, then A and B is going to be true. If A is true and B is false, then A and B is going to evaluate to false. If A is false and B is true, then A and B is going to evaluate to false. And then finally, if A is false and B is false, then A and B would also evaluate to false. Now let's take a look at a very simple example just to see how we would use the AND operation. So let's say we want to check if some score, which we call S, is between 90 and 100. So maybe we're checking if a particular exam or an assignment gave us an A for that exam or assignment. The way that we would do this is we would have our two expressions be that if S is greater than or equal to 90, and then also that s is less than or equal to 100. So because we want to check to see if s is between 90 and 100. So that means it has to be greater than or equal to 90, and it also has to be less than or equal to 100 at the same time. So we have these two Boolean expressions, and then we just combine them with the AND operation. So we would say s greater than or equal to 90 and s less than or equal to 100. And that would give us our complete expression here. Now you might be thinking, why can't we just do it like somewhere where we would do like 90 less than or equal to s less than or equal to 100? So I'm going to try to write this out here. So why can't we do something like this where we have 90 less than equal to s less than equal to 100. So why wouldn't this work? And the reason why this does not work at all is because when we're using a Boolean operation, such as the AND operation, we can only compare two values at the same time. So here we're trying to compare three values. We're trying to compare 90, s, and 100. We can't do that with the AND operation. We have to do two at a time. So what we need to do is we need to split this up. We need to check that 90 is less than or equal to s, and that s is less than or equal to 100. But we can't do something like this. This does not work. We have to go with this approach that we have down here. Let's now take a look at the Boolean OR operation. So once again, we'll say a and b are Boolean expressions, and we'll denote this by saying a or b, or sometimes it's denoted as a plus b, either one is fine. But we say a or b is true if a is true, b is true, or both are true. So as long as at least one of the two Boolean expressions is true, a or b is going to be true. Now if both of them are false, then a or b must be false. So we have another truth table here to show this. So the first row, a and b are both true, so a or b is going to be true. If you take a look at the second row, a is true, b is false, but one of them is still true, so a or b is true. The third row, if we take a look, a is false, b is true. Once again, at least one of these is true, so a or b is true. But if you take a look at the last row, both a and b are false, therefore a or b must be false because neither one of them is true. And let me give you an example here. So let's say we want to check if a student is majoring in math or computer science. So we have two Boolean expressions combined with the word or, once again in capital letters. So we're checking major. So major is our variable that stores the major of our student. So the major is equal to math or major is equal to computer science. So as long as at least one of these is true, then this whole thing is going to be true. But if the student is majoring in like history or something, then this whole expression is going to be false. We'll now take a look at the Boolean NOT operation. So for this one, let's say we have an expression a. So a is our Boolean expression. And we denote this as not a, or just a with a bar over it. We say this is true if a is false, and not a is false if a is true. So notice here that we don't have two Boolean expressions. The not operation only applies to a single Boolean expression. So here's the truth table for it. So if a is true, not a is going to be false. And if a is false, not a is going to be true. So for example, let's say we want to check if a student's GPA is not above 3.5. Well, the way we can do that, and I've actually showed two different ways of representing this, but the way to use the not operator is this part right here, where we're checking that the not GPA greater than 35. I'm sorry, 3.5, not 35. If it's not above 3.5, then that would be true. Otherwise, it'd be false. What I have over here on the right is another way to represent it. I'm not going to get into details of showing why this is the case, but to say if something is not, where the GPA is not greater than 3.5 is the same thing as checking if the GPA is less than or equal to 3.5. So both of these would actually result in the same truth values, but the one on the left is how we would do it using the not operator.